Well, hello guys, here Mr. G with another video. This time we're going to be doing a question for the grade 11, and it was question 6 from the November 2022 done in the Eastern Cape. But before we carry on, don't forget to subscribe for the channel so you can get all notifications and videos I post on regular basis. This question is related to electrostatic and say that two small spheres, each of mass 5 grams, are arranged as shown in the diagram below. Q1 has a charge of 4,5 times 10 to the minus 9 coulombs. It is positive. Is suspended from a light inextensible string secure to a support. Q2, with its charge of negative 2,5 times 10 to the minus 9 coulombs, is placed vertically below Q1 so that both charges are in straight line. Both spheres come to equilibrium, which means they are not moving when Q2 is 3 centimeters from Q1. Ignore the effect of air friction. The only data I am going to add here is the mass. The mass 1 is equal to 5 grams, as well as mass 2 that is equal to 2 grams, also 5 grams. Both of them are the same. Both of them are 5 grams, and this is the picture of what is happening there. The other thing is at rest, so velocity is 0. They are at equilibrium. Question 6.1.1, calculate the number of electrons that were removed from Q1 to give it a charge of positive 5 times 10 to the minus 9 coulombs. Assume that the sphere was neutral before being charged. And in this question, we're looking for the number of electrons that were transferred there. Now, very simple. What formula are we going to look for? So we go to this specific part of the formula, the electrostatic. We're going to look for this formula, which by accident it looks like it moved. Number of electrons is equal to the charge divided by the charge of 1 electron. And the charge of 1 electron, or the elementary charge, that stands for elementary charge, it is here. The charge of electron, or elementary charge, is negative 1,6 times 10 to the minus 19 coulombs. So everything is here, and therefore we're going to calculate it here. Let's do it on this point, 6.1.1. We are going to write the formula exactly as it is there. Number of electrons is equal to charge divided by the charge of 1 electron, and when you substitute, we're working with a positive 4, let's erase this one, 4,5 times 10 to the minus 9. You do not have to substitute the sign. However, if you do substitute the sign here, which is positive in this case, make sure the final answer is positive. Final answer must be positive, okay? So this is 1,6 times 10 to the minus 19. If I were you, I will not substitute that positive there. So the number of electrons is equal to 2,81 times 10 to the 10 electrons. This is a very good question, and you know, it's not just a good question for the grade 11, but also for the grade 10s, because it is applicable for the grade 10 to calculate the number of electrons there. Okay, that was quite simple, and that is 3 marks. Let's give the marks. There will be 1 mark for the formula, 1 for the substitution, and 1 for the final answer or calculation. Okay, so let's go to question 6.1.2. Draw a label free body diagram showing all the forces acting on sphere 1. So for sphere 1, what forces are acting there? And be careful, it is a little bit tricky. So let's answer that question here, 6.1.2. Alright, so let's first of all draw it on the charges. Let's do a force diagram on this charge. What forces are acting here? There is not that bad. Note there is 3 marks, therefore there must be 3 forces. One of them is tension, that you can see clear, the tension on the rope. Okay, that is the first force. The second force is going to be the weight, because there is mass, so there is weight down. This one is weight down, and the most important force in this specific question, because we're working with electrostatic, is the electrostatic force from the negative charge on the positive charge. This force here, I'm going to call it force 2 on 1. That is the three forces acting on the charge, and therefore we must do it like that in a free body diagram. So here I'm going to draw a dot, and then I'm going to have a tension up here. This is tension, then down will be two forces. They're supposed to be along the same line, but let's do it one next to each other because I know you like it this way. So this one will be weight, and then I'm going to draw here, maybe if I use another color it would be better. Here is going to be the electrostatic force. Okay, this one is force from charge 2 on 1, and this is the free body diagram. The actual correct way to do it is one on top of the other along the same line, but let's do it like this. And guys, nothing to say, there will be 3 marks. Instead of weight you write FG, instead of weight you write FG, you will get the mark. It's fine, it's not a problem there. And that one is question 6.1.2. Let's go to question 6.1.3. States Coulomb's law in what? It's a little bit long. Let's write it down in a new page. And then this law states that the magnitude of the electrostatic force exerted by 2 point charges on each other is directly proportional to the product of the magnitude of the charges. That is the first mark. The electrostatic force is directly proportional to the product of the magnitude of the charges. You'll get 1 mark for saying that part of the statement, even if you stop right there. And the second part says that the magnitude of that electrostatic force is inversely proportional to the square of the distance between them, and this one is the second mark. So that is another mark for that part. Now, question 6.1.4, calculate the magnitude of the tension in the string. Now, to calculate the magnitude of the tension in the string here, we have to apply Newton's first law. The object is not moving, is at equilibrium. We do have the free body diagram on this side. We do not have to redo it. It is working in the y-axis, and we are going to calculate the tension on the rope there. So we are going to answer that question on this side here, question 6.1.4. We're going to start with Newton's first law. F net is equal to 0 because the object is not moving there. Okay, so what forces are acting on that object? And in this case, I'm going to select up as positive, but it's not really a big issue here because the object is not moving at the end. Okay, so what forces are there? There is tension minus weight minus the electrostatic force. I'm going to write electrostatic force in this way. I'm going to not write the symbols here. This is equal to 0. Okay, so when you rearrange this one, you will get that tension is equal to weight plus the electrostatic force, and all we have to do is to calculate each of these forces here, which you can do it individual or you can substitute everything in the formula there. Weight, is mass multiplied by acceleration due to gravity, and the electrostatic force, you have to use Coulomb's law. The electrostatic force is equal to K, the product of Q1. Let's use capital symbols there. Q1, Q2 divided by the distance squared. So that is how we're going to use this or calculate this electrostatic force here. It's quite simple. Let's write the formula here. Let's go to a new page because it's getting now a little bit too on each other. Let's write it to the new page. Here we are, much better. We don't have to stress about space now. Alright, so now we go here, this formula, you get it in the formula. Same place where we go the other formula for the number of electrons. Here is the formula for calculating the force, the electrostatic force, and here is the value for K. So please make sure you come in here and you look for the value of Okay, so let's go there to that page of us and do the substitution here. Okay, now this one is 9 times 9 times 10 to the 9 times the first charge was 4,5 times 10 to the minus 9 times the second charge was 2,5 times 10 to the minus 9. Note, remember, you do not substitute the signs of the charges in this formula. Remember to not substitute the minus in this side here, otherwise you're going to make a mistake. And the distance is 3 centimeters. Remember, you do have to convert. So you will get that is 0,03 and everything, guys. Then you calculate the electrostatic force here. I get that the answer here is 1,13 times 10 to the minus 4 Newton. Okay, so now we are coming back here. We calculate the weight. We can calculate it here. We can calculate the separated. It's entirely up to you. It's quite simple because weight, remember, is weight is equal to mass multiplied by acceleration due to gravity. So it's entirely up to you. However, remember the mass of the object. Let's maybe just write it here. The mass of the object was 5 grams, but we cannot work in grams. So the mass we're going to work is 5 divided by 1000, and that is going to be equal to 0,005 kilograms. Remember, we work in kilograms. All right, so now we can calculate weight. If you want, you can calculate it here. It's 0,005 multiplied by 9,8. Okay, and then you will get 9,8, 0,049 Newton. All we have to do now is to add. So we are coming here, tension is equal to 0,049 plus 1,13 times 10 to the minus 4. And the answer will be 0,049 Newton. Guys, this is the answer. But remember the following. You don't have to do the question this way. You can substitute everything within the same formula. Now, if you do this here, you will get 1 mark for Newton's first law. Okay? You will get 1 mark for the substitution on this side here, the denominator, 1 mark for the other part here, this one here, and then 1 part for the final answer. Those are the marks in this specific question here. And here we are. The next question, which is, let us still say 2-point charges S and T are placed at 0,5 meter apart, as shown in the diagram below. S carries a charge of positive 45 microcoulombs and T a charge of negative 30 microcoulomb. Point A is 0,1 meters to the right of point T on the same line as the 2-point charges. You see them here. Define electric field at a point. And we'll go to the new page for that. We're going to a continuation here. This is question 6.2.1. And here, this is the definition. Electric field at a point is the electrostatic force experienced per unit positive point placed at that point. Now here, there's 2 marks for that, but be careful. The word positive, if it's not there, you won't get the mark. Force experienced per unit positive charge placed at that point. That is the definition for electric field at a point. What is next? Draw the electric field pattern between the 2-point charge, between S and T. We having a positive and we having a negative. So how are we going to draw this one? Now we have a positive and a negative charge, and we are going to draw the lines in this specific way. Now we're starting from the positive and we ending in the negative. The first line is straight, it's from positive to negative, and then as from there, all the lines will have a little turn like this one there. Okay, so this is the correct way of drawing this line. Note the following: this line, I've seen people doing this and then turning. No, it is not like that. They all turn since they come out of the chart. They come at the right angle, but they start turning immediately, and then that is how to draw those lines on that specific side there, all the way to that one, and then you don't have to draw all of them to the other side. These ones will eventually go there. Remember, they're supposed to be in this way, and then those lines will come here. No lines will cross or touch each other, so be careful with that one, and that one is like this. I always say the more lines you draw, the more probability of making mistakes. So don't draw many lines there. It's not necessarily. So this one is the drawing of the two charges here, okay? And there will be 3 marks for that one. Now the 3 marks here will be 1 for the shape, will be 1 for the direction, that you can see that they are going from positive to negative, that will carry 1 mark, all of them. And then the other one is lines not starting from the same point, which means no lines crossing or no lines touching each other. Those will be the 3 marks. And to finish here, they say calculate the net electric field at point A due to the 2-point charges. So you're looking for the net electric field here, and let's have an analysis right here in the picture before we start solving this question. Remember, this point charge is always going to be a positive. These points are always positive, and therefore it will have an influence due to S as well as to T. S is going to be pushing that positive away, so we are going to call this one here electric field S. This one is coming through S and is pointing to the right, and for instance T is going to be pointing to the left, because T is negative, therefore it's going to be pulling that charge. So the electric field will be to the left, electric field due to charge T. That is important. So they not necessarily are equal. We are going to calculate now the net electric field, but that will be the drawing of the electric field. So what you need to know is that they are pointing in the opposite direction. So at the end, you have to subtract in this specific case. So note the direction here. Please, this is the important when you do the calculations right now. Okay, now maybe just for this question we can start at this point here. Okay, you need to know that the net electric field is equal to the vector addition of electric field S plus electric field T. That is a vector addition. Once you do this one, you are coming now to the point when you select direction. So in this case, we are going to write, for example, right is positive. So the vectors that are pointing to the right are positive, and the vectors that are pointing to the left are negative. Okay, so from here is where we write the new one. We say E net, same story, is equal to ES is positive because I say right is positive, ES minus ET is negative because I say right is positive, and ET is pointing left. Okay, so this is important in this case. And then guys, the rest is substitute and calculate. Okay, how do we calculate using the electric field at this specific point? The formulas are there, I'm going to show you, but the electric field is equal to K multiplied by the charge divided by the distance squared. Now that is the formula for electric field at a point that we are going to be using, but I just wanted to know the following. The distance from S to the point is the addition of 0.15 plus 0.1. So that's all. Saying that, we're going to a new page to finish this question. This question has been a little bit long, so it's 6.2.3. Now remember, everything we did right there, E net is equal to ES plus ET. I'm going to use the vector notation here. Then I'm going to write positive, and all this will become E net equal to ES plus ET. Okay? Now here is the formula. I told you I'm going to show you the formula. It's the formula with the substitution of the constant. And now all we have to do is to calculate for each of them. So let's calculate here ES, for example, is equal to K charge, this is charge S divided by distance S squared. So ES, when you substitute in here, you will get 9 times 10 to the 9. Remember, do not substitute the signs here again. This one, the Q or charge S, is 45 microcoulomb. So it's 45 times 10 to the minus 6 divided by the distance. And the distance was, I'm going to write 0.15 plus 0.1, all that squared. That will give you ES. So this first one will give you 6.48 times 10 to the 6 Newton per coulomb, and then we have to do the same for ET. Okay, and here we have the calculations. All we have to do now is to come here in it. Remember, this one is a negative 1 here. What is wrong with me? There is a negative 1. So we get now that is equal to ES, which is 6.48 times 10 to the 6 minus ET, which is 2.7 times 10 to the 7. So E net is equal to, we're going to get negative 2.05 times 10 to the 7 Newton per coulomb. Now, what is the meaning of this minus here? That is direction. Remember, we said write this positive, it means this one is to the left. So the final answer, let's write E net is equal to 2.05 times 10 to the 7 Newton per coulomb. This is minus 1 per coulomb left. And that is the final answer for this question, guys. And finally, we are done with this question. Question is a little bit long. So there is 1 mark for this formula, wherever you write the formula. 1 mark for this substitution, 1 mark for this substitution here for T, 1 mark for subtracting the two of them, and 1 mark for the final answer. And that will give me a 5. I'm missing a mark here. The mark is for the direction. There's 1 mark they given for the direction in this specific question. I hope you understand. It's a very good question. It's a little bit long, but well, it's a question like that. So it's a very good question also for the grade 12. I hope it helped. Please try to do the question once more if you didn't try, and then see if it's correct. Thank you for watching. I hope it helps. Subscribe for the channel, thumb up. I'll see you next time. Next time we're going to be solving a question on electric circuit here. You can see the question, which will be the last one of the question paper. So don't miss that video. Thumb up, subscribe for the channel. Mr. G here.